Today we have disassembled a car's starter motor, giving it an overhaul by inspecting all the parts, cleaning them, putting it back together. So it's an opportunity to see what a starter motor looks like on the inside. So over here we have the cover, the rear cover of the starter motor, which is held onto by these two bolt screws here and two small screws there. This thing here is the magnetic switch, or also known as a solenoid. These are the external connections that come off the battery. This is bolted onto the main body of the starter motor, and inside is the solenoid. There it is here, that goes in there, and this spring also goes in here along with the solenoid, so we can push the solenoid back into position when the starter motor isn't running, because what that does is it pushes against this lever here in the pinion gear housing, where this little gear here will pop out, and then once the starter motor is engaged, it will then turn the flywheel, which then cranks the engine. Now for this thing to pop back in, so it's not interfering with the flywheel, that's where this spring will come into play, pushing it back in. This here is basically the starter motor itself, where it has the bushings 1, 2, 3. When electricity is flowing through it, it creates a magnetic field, which then forces the main axle of the starter motor to spin. We have, like we said, the magnetic switch with a solenoid which pushes out the pinion gear, and then the starter motor will spin, turning the flywheel, and the flywheel cranks the engine. Once the starter motor is disengaged, the spring will push back the pinion gear. The starter motor has already stopped spinning. And what we're doing here is we're inspecting all the parts. We inspect the bushings, and if these are fairly worn out, then most likely that's when you have starter motor problems. These are the areas where those bushings rub against, because the electricity is flowing through. It's just making contact here, and that's why you can see these black scuff marks. So we just give those a clean afterwards. I've already cleaned all the parts. I'm just going to give them a close inspection afterwards. There are certain areas of the starter motor that need a lubrication with a special grease, and the other things I would check is the lever for the pinion gear, the solenoid itself, the magnetic switch. Other times when starter motors don't work is because the magnetic switch isn't working, so you can just have the magnetic switch replaced instead of the entire starter motor, but that is provided that you can find the specific parts for the specific starter motor. Normally it's just easier to replace the entire starter motor than giving it an overhaul. So that's just a brief explanation of what a starter motor looks like on the inside. If you've ever seen small toy electric motors, if you ever pulled one apart, the concept is the same. This is just a larger scale of it. You know, you've got your main shaft that sits inside the housing, where inside the housing it's got those magnets, and this coil, the axle with a coil, sits in a magnetic field which is activated when electricity is run through it, and with these bushings here, like we said before, make contact with the rear of the axle, causing it to spin. It's your basic electric motor, but a lot more powerful. This particular starter motor has a power of 1 kilowatt, which is 1.36 horsepower to be exact. The axle slash shaft of the starter motor, also known as the armature. In this aspect here, we are inspecting the rear end of the armature, where the bushings make contact with, and we check to see that the width is within specification of the manufacturer. So if it is, obviously that's good. If it isn't, we have to replace the entire armature from the starter motor. Things we have to check on the commuter and the armature is doing a ground test and an open circuit test. So if any of these two tests fail, again, that's another sign that you would have to replace the commuter and the armature. For the ground test, you don't want to hear this sound when we do the test. So we put one end on the armature, one end on the commuter. There doesn't seem to be any continuity. We can't hear any beeping sound. So that means that the armature and the commuter isn't grounded. So far, it's passing the test. Now for the open circuit test, we want to hear the continuity sound, which is that there. And what we do here is we're checking each little segment here on the armature, and you just simply place one prong on one segment and the other one next to it, or the one after. Either case, we have to do all. So there is no open circuit, there's continuity. That's a good sign. I will go ahead and test each one separately. Testing each one separately, making sure there's no open circuit. The field coil as well requires a ground test, so we don't want to hear that constant beeping sound. So we'll be testing the brushes here, the connector here, the magnets inside. So one prong goes on one area, another prong can go, say, at the connection there, or one of the magnets there, and we will hope not to hear any of those sounds, the continuity sound, that is. Checking the thickness of the brushes, those magnets inside the field coil, they seem to be within spec, so there's no need to replace the field coil either. Testing now the magnetic switch. I'm going to test the connectors here. This connector comes off the negative from the battery, and this connector here connects to the starter motor. So what we want to do is check for continuity. So we do want to hear that constant beeping sound. So let's see. So far nothing. It's also difficult with one hand. Let's see. There we go. So that's fine. Again, we'll be doing another continuity test where we do want to hear that constant beeping sound. And in this instance, we'll be checking for the open circuit test for the grounding. So one connection, one prong goes here, where the negative battery terminal goes, and the other one just on the body of the magnetic switch. Had no continuity, so at first glance it appeared that the magnetic switch would have needed replacing, but then I thought of just slightly sanding the contact areas, cleaning up here the connection where the negative battery terminal goes to, and just the body of the magnetic switch. So this time we should get a continuity sound. There we go. So magnetic switch is okay. So now it's just a matter of lubricating some specific parts according to the manufacturer for areas that need lubrication, and then just reassembling all the parts together and giving it a test run by connecting it to a car battery, obviously out of the car, to make sure the motor runs as it should.